Hello and welcome back to the channel Smart Techie. So data lakes emerged more than a decade ago to solve a growing problems in definite in data space, right? So the need for a scalable or low cost data repository that allowed organizations to easily store all data types from a diverse set of sources and then analyze that data to make evidence-based business decisions, right? But what about the data warehouse? We'll definitely touch upon that point, like what exactly data warehouse. But before that, which was the de facto solution for storing and analyzing structured data, and preceded the data lake by 30 years. Not exactly 30 years, it might be 40 years, 50 years, or it might be go all the way long history. Okay, so it couldn't accommodate these new big data projects and their fast-paced acquisition models, many of which envision easily storing petabytes of data in structured and semi-structured forms. With the future of big data looming, the data lake seem like the answer. Okay, so what I mean is an ideal way to gather, store, and analyze enormous amount of data in one location, right? So interest in data lakes skyrocketed for one simple reason. Okay, that is nothing but the most organizations consider data as a very important asset, and obviously that is a very important asset. Without data, most of the organization might die. Okay, so and the systems of the time couldn't handle the variety, right? For decades, organizations have collected structured data from enterprise applications, and now they are supplementing it with these newer newer forms of semi-structured data from web pages, social media sites, mobile phones, Internet of Things. We can say that is nothing but the IoT devices and many other sources, including shared data sets. Right. So data scientists, business analysts, and line of business professionals still need a way to easily capture, store, access, and analyze that data. Right. So if you say the initial data lakes were deployed on premises, right, mostly using open source tools from Apache Hadoop ecosystems, okay, and some other open source platforms like that. So in the decade since data lake were first introduced, cloud computing has evolved, and definitely data storage technologies have matured, right? So better and easier way to create data lakes have emerged that leverage the power, flexibility, and near infinite scalability of the cloud, right? In short, if we talk about what exactly a data lake is nothing but a centralized repository that allows you to store all kind of structured and unstructured data. At any scale, right? So we can store any kind of massive volume of data into the data lake, where it can be structured, it may be in unstructured form. So those can be stored in the data lake, right? Store data as is without having to first structure the data, right? So some of the time when we are really using some RDBMS system, or maybe if you talk about some data warehouse, so what we have to do is really massage the data and clean the data, and we have to transform, I would say, from a unstructured data structure to a structured way of storing the data, right? Otherwise we can't store JSON formatted data into a tabular format, right, as is. So that we have to make a massage on that, and then we can store into the data warehouse or maybe some RDBMS data store. And also run different types of analytics for dashboards and visualizations. And other than that, also we can do the big data processing, real-time analytics, and machine learning as well. So these are the very important points where we can really define what exactly the data lake is. So on that note, if we talk about like data lake, then this is how the data lake would look like, right? So in one side we can say there are the data sources, and next we'll see the data lake, and the other side we'll find all those analytic stuffs, right? So now data sources would be like networks, maybe endpoints, cloud applications, users, maybe some IoT stuff, and any other thing, right? So that can be as a data source. So from that data source, the data will ingested into our data lake. So we can store any kind of in any format, right? That we have already discussed as a definition. So and then once data is available in the data lake, so next is there might be downstream applications or downstream tooling system or dashboard system where data can be consumed, and they can really massage the data as for their requirement to display in the dashboard, or maybe sending those massage data to some other downstream system, or maybe some into some analytics tool, right? So these are the things what it will happen. What exactly the cloud data lake, right? So cloud data lake is nothing but what exactly the what's behind the metaphoric name data lake is. James Dixon, who founded and served as a chief technology officer for Pentaho, coined the term data lake to describe a new type of data repository for storing massive amount of raw data in its native form in a single location, right? So that's what that's what we are going to talk about, the history of the data lake, why the idea emerged, and how it really has evolved, right? So it explores what data lakes can do, and where traditional data lake have fallen short of ever expanding expectations, right? So it spells out data lake strategies, and definitely we'll explain where the cloud data lake fits in, right? Prior to the data lake, most analytics systems store specific type of data and using a predefined database structure. For example, I would say like data warehouses were built primarily for analytics using relational databases that included a schema to define tables of structured data in orderly columns and rows, right? So by contrast, the hope of data lakes was to store many data business community for reporting and analytics. Correct. The goal was to enable organizations to explore, refine, and analyze petabytes, maybe terabytes of information without a predetermined notion of structure, right? So the most important thing to understand about a data lake is not how it is constructed, but what it enables, right? It's a comprehensive way to explore, refine, and analyze petabytes of information constantly arriving from multiple data sources, as we are seeing in this as you are seeing that in this slide itself, right? So there are multiple data sources, and we are ingesting the data into the data lake, right? So now data lake has full capability to store any structure of data into the data lake, right? So let's say 1 petabyte of data is equivalent to 1 million gigabytes, right? About 500 billion pages of standard printed text, or maybe some 58K high definition 2 hours of movies, right? So data lakes were conceived for business users to explore and analyze petabytes or terabytes or maybe zettabytes of data, right? So if we talk about the data lake in nutshell is what it is, right? We talk about it's all in raw format, and it can be large as petabytes, terabytes, or zettabytes of data, right? So, and definitely it's undefined in the sense like it's not at all structured, and what kind of data structure it is. It can be a structure, it can be a semi-structured, it can be a unstructured, or the undefined source of data, right? So that's what it is. We shouldn't really confuse between data lake and the data warehouse, right? So raw data is data that has not yet been processed. Definitely for a purpose, right? So perhaps the greatest difference between data lakes and data warehouse is the varying structure of raw versus processed data. Data lakes are primarily store raw unprocessed data, while data warehouse stores processed and refined data, right? So because of this, data lake typically require much larger storage capacity than data warehouse, because whatever the data available in the data lake, it's completely unrefined, right? Unrefined. So when we are really storing the data in data warehouse, before that we are already cleaning the data, and we are just training all unwanted data sets from the whole data set, right? So additionally, raw unprocessed data is malleable, can be quickly analyzed for any purpose, right? And it is ideal for machine learning, right? So that's why you can say like the risk of all the raw data, however, is that data lakes sometimes become data swamp without appropriate data quality and data governance measure in place, right? So in contrast, data warehouses, by storing only processed data, save on definitely price in cost. Definitely I would say the cost, saves cost from the storage side of the house, by not maintaining data that may never be used, right? So additionally, processed data can be easily understood by a large audience, right? That's why business analysts are mostly using data from the data warehouse, right? So when we talk about the purpose, purpose of the data lake, versus the purpose of data warehouse, it's undetermined versus in use, right? So what exactly that is, the purpose of individual data pieces in a data lake is not fixed. Okay, so raw data flows into a data lake, sometimes with a specific future use in mind, and sometimes just to have on hand, right? So this means that data lakes have so then in contrast, when we're talking about processed data, so processed data is raw data that has been put to a specific use case, right? So since data warehouses only house processed data, all of the data in a data warehouse has been used for a specific purpose. So within the particular organization. So this means that storage space is not wasted, and definitely it's saving the cost, right? And when we're talking about who are the users for the data lake versus the data warehouse, for the data lake, so the data scientists are the one who are mostly using the data from the data lake. However, the data lakes are often difficult to navigate by those unfamiliar with unprocessed data. So raw unstructured data usually requires a data scientist and specialized tools to understand and translate it for any specific business use case. Right. So alternatively, there is growing momentum behind data preparation tools that create self-service access to the information stored in the data lake. Right. So then when we're talking about like processed data is used in charts, spreadsheets, tables, and more. So that most, if not all, not all, then employees at all companies can read it at least, right? So processed data like that stored in data warehouse only require that the user be familiar with the topic represented. That means like whoever is really looking into the data, he or she, must aware about like those data is on which context, right? The context should be, being out by the user, whoever is using the data. So in the space of accessibility, to the data lake versus the data warehouse, definitely, accessing to the data lake is very much flexible. There is no much, security added to the data lake. However, in our data warehouse, it's proficiently secure. Right. So accessibility and ease of use refers to the use of data repository as a whole, right? So not the data within them. So data lake architecture has no structure and is therefore easy to access and easy to change. So now, plus any changes that are made to the data can be done quickly, since a data lake definitely have very few limitations, right? So, in contrast, data warehouse are by design more structured. So one major benefit of data warehouse architecture is that the processing and structure of data makes the data itself easier to decipher, and the limitations of structure make data warehouse difficult and costly to manipulate. Okay, so that's what it is. Okay, so now these are the different criteria or attributes, comparing between a data lake and a data warehouse. So hope you will not confuse further. Like when we're talking about data lake, we can visualize these are the things, and when we're talking about data warehouse, then what are the things we need to visualize, right? So visualize in the sense like we need to really think ourselves like what's supposed to be comparing to data lake. So those are the things we need to keep in mind when we are really talking about any one of the topic, either a data lake or data warehouse. So on that note, when we're jumping on the traditional data lake, so every company, every organization, whoever is data intensive, and they are mostly playing on the data, and those and most of the companies they really huddling into this kind of architecture pattern when they are building the data lake. So it's straightforward. One part, there are three parts. One is capturing the data, and other part is the storing the data, and the third one is delivering the data, right? So the one thing is like how people really really capture the data, right? And these things will talk about a little bit in that. And when we are talking about the capturing data, so in the sense like we already saw like there are lots of multiple data sources from where we can really capture the data, right? So once we know like this is the source, either we can write our own producers or maybe own ingestion process to ingest the data from this from any of the data source to the data lake. So data sources can be any third-party CSV files, streaming events, so any kind of data source, right? So when we are trying to ingest the data to the data lake, so it can be any kind of collect process or producer process, right? So we can collect it, transform if we want, and partition it and route the data to the right data lake, right? So now once data is available in the data lake, so we know like it's in a unstructured format or semi-structured format, or maybe some of them are structured format, right? So definitely not necessarily all the data is in structured format, right? So once data is stored into our data lake, then it's a one-stop shop, right? So all the data, every kind of data is now available in data lake. So now anyone can extract the data from here, right? So what some of the organization or some of the architects, what they used to do is they build some of the other tooling system, catalog system around the data lake, where in virtually that will consider as a structured way of accessing the data, right? But under the hood, the data is not at all structured, right? So that data has to be catalog in the sense like, that has to be defined which data is for what, right? Otherwise, it just a mess of data, or it's just a some set of data but without any meaning, right? So once I'll build the catalog, define the schema around that, and you'll try to version the schema, right? Version the schema, or maybe versioning the dataset, right? So you have to version it out so that anytime it's getting deleted or anytime it's getting updated or overridden, so you should have the way to really go back to the history and see like what are the what changes happen to that dataset, right? So that has to be there. And definitely inventory of the data to a target destination. So you have to define, so one way we have defined how to push the data into data lake. So there in the capture state we did that, and when we are storing and trying to deliver that deliver the data to a different destination, so we need to apply all this cataloging and loading mechanism to around the data lake, so that will be the data will be treated in a good manner, in the sense like, and some defined purpose, rather than it just a mess of data set. So once those things are prepare and perform, then the data from the data lake is ready to consume, right? So then the consumer side will come in the picture. So that is nothing but the deliver side of house, right? So the deliver is nothing but the rapid insights and business results from all data, right? So destination could be any, right? We can store that data into some data warehouse, or we can store that data some, Elastic server, or we can, that can be pull and sent to some visualization system for the analytics purpose, right? So that can be done. So destinations could be data is loaded to a target destination. It can be database, tables, and schema, or as we say, like any caching system or anything, right, where we can send the data in a structured manner, right? And then from there, any of the downstream team or any downstream application, they can really consume those data to do their own work, right? So we're talking when talking about all these things, definitely, we need to also think about like what could be go wrong, right? When we are really designing the thing in a very professional manner, or maybe this will definitely scalable. It would be definitely very easy to flow the data from one end to other. But what could be go wrong, right? So definitely, we would say like as you say, like software frameworks that distributes data storage and processing among commodity hardwares located in on-premise data centers. Okay, Hadoop includes a file system called HDFS, right? That enables a customer to store data in its naive form, right? So the ecosystem also includes open source equivalent to the structured, SQL. We are saying like that, structured query language, the standard language used to communicate with a database, right? Along with BAS and interactive data processing technologies, right? So cluster management utility and other necessary data platform components, right? But unfortunately, many of these on-premise data lake projects fail to fulfill the promise of data lake computing. And definitely on that note, so that's great. That thank you so much for visiting the channel, and please share and subscribe the channel. Bye and take care for now. See you then.